Okay, so we're converting 50 miles an hour to feet per second. And so we write 50 miles per 1 hour, write it as a fraction, and then you multiply. How do you know what to put on the next fraction?
It's the feet and the mile.
Yeah, you're motivated by what you want to cancel,
Yes.
right? What do I want to cancel?
1 mile on the
Miles.
denominator.
You can start with hours or miles. I'll just start with the miles. I want to get rid of miles, right? I don't want miles in the end. If you did hours first, that's okay too. Only do one thing at a time, though. Don't try to do miles and hours both on the same fractions. One at a time.
Get all together.
Yeah. So I'm getting rid of miles. So what do I put on the top?
The
Feet.
The feet. And then look on the chart. 1 mile is 5,280 feet. So if I stop the problem right now, the miles cancel out. Don't they? That's good. But if I stop right now, I'm going to have feet per hour. I don't want hours.
1 second.
Is that good so far? So where do I put the hours?
And then I make time 1 hour over 60 minutes,
Yeah.
and then 1 minute over 60 seconds.
Am I going too quick? Are you guys up with me? You're tracking with what's happening. So you're always the next step always comes by getting rid of what you don't want. Is everybody seeing that? Mm-hmm. So if I was to stop the problem right now, which units are left still there?
The hour and the
Feet per hour. And I want the feet, but I don't want the hour. So the next fraction better get rid of the hours, huh? So hours are down below. So I have to put them up above so they'll cancel. Right? You always cross cancel.
And then minutes.
Now, what do you know easily for hours? If you want to, you could go. Did some of you guys go straight to seconds? That's okay if you're really good.
120.
You could go straight, but I think it might be easier to just go to minutes first. You don't have to. But you know the conversion between hours and minutes pretty easily, right?
Yes.
3,000.
Yeah, 1 hour, 60 minutes. But yeah, if you wanted to go straight to seconds, you get 3,600 seconds. You can go straight to it. That's okay also. You know what I mean? Some of you do it that way. Either way is fine. If I stop the problem right now, what units are left standing?
Minutes and feet.
Start with the top, feet per minute. Feet per minute. I want feet. I don't want minutes.
So get rid of
Do another. Where do you put minutes? Put them on the top. Minutes cancel. Seconds down below. What's the conversion there? 1 minute, 60 seconds. So if I stop the problem right now, which units are left standing?
feet and
Feet per
seconds.
second.
So I've arrived. Any number in the top you multiply, any number in the bottom you divide.
Divided by 360.
73.33333 feet per second. And we got to do our rounding thing in just a second. But so far so good. Is that coming out?
So do you divide by 60 and then divide by 60?
Exactly.
73.33333.
Now let's do our rounding. How many
2.
significant digits in the original?
2. No.
Does this zero count? Does that zero count?
Yes.
When do zeros count? When they're
they're
after the decimal. So that zero does not count.
So
One
it's 1.
significant digit, huh? Y'all tracking with me? Zeros only count when they're after the decimal.
So would it be 70?
70.
Yeah, good job. So only the 7 is all we're going to use. Look, 1 to the right, it's less than 5, so 70
I would have a big problem.
feet per second on number. Let me double check our answer. What page are we on? 546?
Yes.
Number 10. Yep, exactly, 70. Is that good? Is that okay? You getting the significant digits? Zeros only count when they're after a decimal. A lot to remember, huh?
After the decimal count. So this is the third time I write it.
All right. All right, let's go to the last thing, and then we can review for the test at 546. Okay. Let's go to the temperature conversion. These will be easy. These will be cake for you. Page 547. There's two temperature conversion formulas at the middle of your yellow sheet. One of them is Fahrenheit is 9/5 Celsius plus 32, and it's in a box. And the other one is C equals 5/9 F minus 32. Like that.
Where is it? Where is it? Oh, it's right here. Okay.
So there they are. And let's jump down to number 5. All right. It says 12.8 degrees Celsius equals how many degrees Fahrenheit? So they want us to convert from Celsius to Fahrenheit. Okay, so we're going to use one of those two formulas. One of those two formulas. How do we know which one? Well, the one that has in the front what you want. What do I want on this one? I want Fahrenheit. So which one has Fahrenheit in the front? This one. It's the first one. So I use F equals 9/5 C plus 32. And you grab the 12.8 and you just plug it in and you just hit the buttons on your calculator. So it's going to be F is 9/5 times C. C is 12.8 plus 32. Do you all know how to do that on the calculator? The fraction just means divide. So in other words, here's what you'll type. You'll type 9 divided by 5 times 12.8 plus 32. Oh, by the way, it says round to 3 significant figures. So the author just told us, Ms. Bezzera-Nader, to just round to 3 significant figures. So, let me see what we get here. 9 divided by 5 times 12.8 plus 32. I'm getting 55.04. I haven't rounded it yet, though. Did you get that? See if you can get that.
And 3 significant figures.
And then we got to do 3 significant figures.
1, 2.
So the 0 is the third, huh?
The zeros count.
Look 1 to the right. Yeah, that 0 counts because it's after a decimal, huh? Look 1 to the right. It's a 4, which means leave it 55.0. And that's our answer. And that 0 does count because it's after the decimal, huh?
Third significant.
Not making sense. Questions on that one? Y'all able to get that in your calculator?
Can we take one of the first part? 1, 2, 3, or 4?
Yeah, maybe we'll come back to those. Let's move ahead, if you're good with that. I'm going to move ahead to like number 6. Says 75 degrees Fahrenheit equals how many degrees Celsius? So, you got to, on your yellow sheet, you got to grab one of those two formulas. Everybody have the yellow sheet?
Minus 32.
You got one, you got a copy?
Yeah,
Oh, you get yellow?
yeah.
Yeah, great. Do you have one of those at home, yellow sheet?
Yeah.
Oh,
I guess I have one.
at home? Or somewhere?
Yes, yes.
Because I can photocopy one real quick.
Yes. No,
Okay. Okay. So the formula, we're going to use the formula that has which letter in the front?
C.
The C, because we want C, huh? Which is,
So I got 9.6666.
Let's see. So there's the, now notice there's parentheses. You got to do what's in the parentheses first, huh?
That's what I was wondering. Should I do that first?
Yeah, so we got to do what's in the parentheses first. Grab that 75 and plug it in there. Yeah, so do what's in the parentheses first. Subtract those two.
43.
What is it? What's 75 minus 32? It's 43, yeah. And so then you take your calculator and you take 5 divided by 9 times 43. And I'm getting 23.88888. Good, that coming out? And now how many? She said 3. On this whole page it says 3. Round 3 significant digits. So 3, 1, 2, 3, that's the 8. Look 1 to the right. 23.9.
So,
See?
so then it's
I did a mental math.
75 minus 32, which is 48.
Oh, 43.
43.
Must have hit a wrong button, maybe.
Mental
Yeah,
math.
and then you divide.
5 divided by
5 plus
9 times
and-
43.
Oh, okay.
That makes sense. We
So
start
you
with the
still
top.
do times.
Yeah. 5 divided by 9 times 43.
Okay.
You always divide by the numbers under the bar. Is that good? And we can back up to number 1. The earlier ones, I don't want to spend too much. I want to get to that practice exam here. But number 1, basically, it's just asking you the significance of that, of basic temperatures. So it says a hot day in Arizona. I think it gets hot in Arizona.
So we convert it to Fahrenheit?
No, it just wants you to you don't, I mean, you could, that'd be a lot of work though. It just wants you to feel it.
To get the right answer, yeah, because...
Yeah, just kind of a feeling, because I don't really know. I don't really have much of a feeling. I'm used to Fahrenheit.
It can be 1 or 2.
It can't be this, because what would that
Can
be?
be. That's going to be like the sun temperature.
Yeah, that's water boils,
It's
right? 100 is
beyond.
one, so it would be
So
boiling.
I think 43.3 is the...
Yeah, so it's that one.
Oh, I got it.
Now, honestly, I would know whether it's that or 37. 37 seems close to me, but
37? No, it's Arizona. 43 is getting hot.
I just don't have much of a feel for the Celsius. I mean, you're right, that is the answer. I looked in the back, but I'm not sure if I would know looking in the back because I just don't feel Celsius very much. But
43 is kind of hot.
37.
But how do you find the answer?
yeah, you just got to kind of remember that 43 is really hot and 37 is more mild in the Celsius system. So just remember that around 43 is a hot day.
Instead, the hot top would be
So
40.6.
102 is you're
It's a
dead.
hot top.
Yeah, oh yeah. Yeah, because that's boiling. You've been boiled. Yeah,
See, this one
right.
is a soup.
200 degrees Fahrenheit.
Right. Right, exactly. All right, we better get to the practice exam. I think would be our best use of our time that remains. So, let's go talk about that. So I'm now on page 554. I'm jumping to the chapter 3 check test. So you guys have that, right? Number 1 says, okay, 3.00 precision. So 3.00, what is the precision? So there's a difference between precision and accuracy. Let me come down here and do accuracy. In fact, let's start with accuracy. Because that's what we're used to. So I'm going to do number 2 first, actually. Okay, so you with me? So 3.00 accuracy. Let's do that first. Accuracy is significant digits, like we've been doing for the last hour and a half. So as you look at 3.00, tell me, how many of those digits are significant, meaning they matter? Something's significant, it matters, right? If I say that was a significant amount of money to pay for that horse injury. I own a horse and really wish I didn't. They cost you nothing but money constantly. They just had to x-ray it for $400. I about fell out of my seat when my wife told me. I've got daughters that live and die for horses. It's a sickness, really. All right. Anyway, so there was a significant sum to my bank account. Everything with horses is. I'll tell you one horse quote, which I believe in. You know how you can get a small fortune in horses? Start with a large fortune. That's the truth. Horses just take your money. They're nothing but money. All right. Anyway. Some people think they're nice animals, but anyway, enough of that. All right. So significant means it matters. So how many of these digits matter?
3.
All 3. Yeah, these zeros matter because they're after the decimal. Whereas, what if somebody gave me the number 300, no decimal? How many digits would matter?
1.
1. Only that 3 then. Because remember, zeros only matter after the decimal. So all these matter. So the answer is 3 to question 2. Now, I still haven't done question 1. I'm going to go back and do question 1. But everybody okay so far? Zeros. So let me write that. Zeros matter. Well, zeros are significant. Significant after the decimal. Only when they're after the decimal are they significant. You really got to know that for your exam on Monday. Okay, come back up here now. Precision, that's a different animal. Remember from your lecture before? For precision is about the place value. Nothing to do about total number of digits or any of that. Just remember precision means place value. How about that? Maybe that helps. P with P. Precision place value. So what place value does it stop in? What is that? That's the what's place.
Hundreds.
Yeah, right? 2 zeros. 2 zeros. Hundredths place. That's the answer. The precision is the hundredths place. You know how the places go, right? The number 2 places is 2 zeros. So if I give 5.736, whoops, that's a 6 there. I'm just making up numbers to make sure. This is the what's place.
Thousands.
Thousands, because it's 3 places to the right, 3 zeros, thousands, etc. What's this place right here?
10.
Tenths. 1 place, 1 zero, tenths, etc. So you know how the place values work. Well, that's all you got to do for precision. Precision is just about the place value. So this ends in the hundredths. So hundredths is precision. Accuracy is total significant digits. See the difference between them? So remember, P for P, precision, place value. Accuracy means all, for all. How about that? Here. This is how I survived college. I have a terrible memory. I just did tricks all the way through. It helped me. P, precision, place value. Accuracy, all. All the digits matter. All right, let's go to number 3. So number 3. Now we're doing 35.000. So they want to know what's the accuracy. And number 4, kind of messed that up. 35.000.
There's no decimal there, right?
Yeah, are you getting the same copy as me? Yeah, where there's just like a blank?
Yes.
Yeah, that's wrong. And because I looked at the answer key. So there's supposed to be a decimal there. Yeah, mine came out with nothing there too. Put a decimal in there.
Yeah.
I know there is because I looked at the answer key. All right, let's start off with number 3, the accuracy. See if you can do both of those.
1, 2,
Remember, accuracy all, precision place value.
is that 5?
Question,
Mm-hmm.
so accuracy would be the number of
Yeah, beautiful.
Place value بتاع the last zero is gonna be the 1000.
precision would be,
No. Is that the
I'm not sure about
1000? We
the
didn't count
precision.
whatever behind the decimal, only the after the decimal?
Mm-hmm.
Okay, so it's gonna be 1000.
So what's accuracy? All the digits. How many?
5.
5 significant digits. Right?
Mm-hmm.
5. Now, I looked on the answer key for that one, and the answer key said 2. I think it's wrong.
The
So,
answer key's been wrong before too.
yeah, so I think it's wrong. I did all my best to read up on other things and check, and this rule always worked for all the other
I
problems.
did remember her saying that there's certain amount of zeros that are not countable, but I don't remember.
The zeros after the decimal matter, though. That's the rule.
I think she was talking about something like, okay, let's say it's 2.001.
Yeah, those matter.
So then,
Yeah, 2 does. Yeah, any zeros captured in between matter. Yeah, so that would be 4 significant digits on that one. Yeah, those all matter, right? Yeah.
At the top it says spaces are used for commas where would be normally written.
Spaces are used where commas would normally be written.
What's
Okay,
35,000?
The
So
answer
it
key's
is.
wrong.
The answer for...
Oh, that's supposed to be a comma. Thank you.
Yeah, maybe.
I didn't notice that little note. That's supposed to be a comma. Okay,
trick.
that was a trick.
So it should be 2 and 100.
Yeah, so that is why it's only 2. Oh, thanks.
10th and...
Yeah, there's supposed to be a comma there. Thanks. Good observation. So there's supposed to be a comma, I see. So that's why there's only 2. Now everybody see there's only 2?
Yes.
Because now those zeros don't matter, because now they're not after a decimal. Only zeros after a decimal matter. So there's only 2 significant digits. Thank you. Now, precision is the place value of the number. Oh, you know what? Okay, yeah, let me be more clear. I see where we need some clarity here. It means place value of the last significant, let me go back and make sure. Number 2, when was the 100th, right? I get it. Place value of last significant digit. Place value of last significant digit.
Last significant...
Which digit up there? The 3, the 5, the first 0, the second 0, the third 0? Which digit up there? Let me ask you, are these zeros significant?
No.
No, because they're not after decimal, so they're not significant. So what's the last digit that is?
5.
The 5 is the last digit that's significant. That matters. Right? You with me? Okay, so what? Well, what's his place value? What place value is the 5 in?
1,000?
5 what? 5
1,000?
thousand. Not thousandth. Those are to the right of the decimal.
Comma.
It's the thousands. Thousands place, not thousandths.
So we would just
thousands.
write thousands, or would we write
Yeah.
5,000?
No, thousands. Thousands place. Is that making sense? That 5 is in the thousands place, isn't it? And he's the last digit that's significant. So precision is place value of the last significant digit. Accuracy is all the digits. Let's go back and compare. How about precision on this problem? What was the last digit that was significant? Is this 0 significant?
The 100.
Yes, because it was after a decimal, so they matter. So he's the last digit that's significant. What's he in? The hundredths place. Hundredths. Things to the right have the TH, don't they? Anything to the right of the decimal has the TH. Things to the left don't. Right? You know how if you have a big old number, 123.456, you know this is the tenths, hundredths, and thousandths. And then when you go to the left,
Unit.
this is the ones, tens, hundreds, and on you go, huh? Remember that? Good? All right, let's keep going. So number 5, 0.0050. They want the precision. And then number 6, 0.0050 accuracy. Try that one. All right, how we doing? Now, precision is place value of last significant digit. So what digit is the last one that's significant?
10,000.
Is this 0 matter?
Yes.
Yes, it's after a decimal. So it matters. This is the tenths, hundredths,
10,000.
thousandths,
10,000.
10,000ths. That's it, 10,000ths place. That's the precision. What's the accuracy?
I got 3.
Yeah, there's another rule. Remember how I said zeros after the decimal matter? Yeah, but only these two.
Why? Because it have
2.
a number
Oh,
in
I
the
was
middle?
thinking the last one would drop off.
Yeah.
But it's the first 2 drop off.
2 significant digits. Yeah. Zero. So
Three.
how do I put it? Zeros that are after the decimal, as long as there's a non-zero number in the front. It's a lot of rules. Let me write that down. So zeros are significant when they are after the decimal and after another number, after a non-zero number. Yeah, there we go. So there's the whole story. I was kind of giving you part of the story. Really, zeros have to have 2 things to matter, to be significant. They have to be after the decimal, and they have to be after some digit that's not 0.
And after what? The last one?
What does that say?
After non-zero number.
Oh.
Yeah, can you read that? Sorry, I'm scribbly. Non-zero number. A number that's not 0. So you see how this 0 and this 0, even though they're after they're not significant. Everybody seeing that? Why those first 2 zeros
How about
after?
the 5?
Yeah, of course he's significant.
So it's
This
3
is just a rule for
significant.
when zeros are significant.
Okay.
All the other numbers are always significant.
All right. So the
But
5
zeros are sometimes yes, sometimes no. Yeah, the 5 is for sure. All numbers that aren't 0 are always significant. No question about it. The only place where there's a question is the zeros. Sometimes yes, sometimes no. All the other numbers are yes always.
Okay.
Does that make sense?
So let me see if I understand this. If I have the decimal point and then 4 zeros after the decimal,
Mm-hmm.
all right? So it's like, it's 4 digits, right? We counted 4, right?
Okay.
It's 4 significant digits. Is that right?
Okay, you got to have, there's 2 conditions.
Uh-huh.
You also have to have a number that's not 0.
Oh, I see that.
Does that make sense? So there's 2 conditions. So it's like, hey, you can apply for this scholarship at Fresno State. Go there for free. If you grew up in Fresno and you've been to the moon. We're all out because we didn't. So, and means you got to do both, huh? So that's what I'm saying here, right? Zeros are significant if they do two things. They got to be after the decimal, but also they've got to be after a number that's not zero. Does that make sense? That's why only this guy is significant. He's the only zero that matters because he comes after a 5, after a number that's not zero. Whereas these guys, they come before the number that's not zero, so they don't matter.
Question.
Everybody tracking with me on that? There's two things you got to do for a zero to count, for a zero to be
So
significant.
this is the other way around.
There's two things it has to do. It has to be after the decimal and after a number that's not zero. If it meets both those conditions, then we count it. All the other numbers, we always count. They're all significant.
Let's say it's 3.00.
Just two zeros?
Do all three count or only the 3?
Good question. Let's ask this zero. Hey, zero. And you too. Hey, zero, are you significant? He'd say, well, am I after the decimal?
Yes.
Yeah. And am I after a number that's not zero? Are these guys after a number that's not zero? Yeah, they're after the 3.
Okay.
Oh, yeah, when I say after, I mean anywhere before them. I don't mean immediately after. Does that make sense? I mean anywhere before them has to be a number that's not zero. See, whereas these zeros, there's nobody before those zeros,
What 0?
Numbers.
these zeros.
Number 6.
That's why none of them counted.
Oh.
None of these counted. Now, if they just would throw in like a 7 in the front or something, then they're all in. Then they would all count.
Okay.
Does that make sense?
Yes.
You got to have a number in the front of them that's not zero, and then they're in the club. They've been to the moon. They can go to Fresno State for free. Right? Does that make sense on that? You got to have a number somewhere else that's not zero, and then everybody after that is in. So there's two conditions. So yeah, these would all be good. This would be 3 digits that are all significant, wouldn't it? Because those zeros come after the decimal and after a number that's not zero.
Two conditions.
So that's kind of tricky. Honestly, I completely forgot. I learned it all again, about 5 hours ago in my office. I went, oh yeah, not this again. I always forget it. And then I had to review it all and get it straight. Yeah, it's pretty tricky. It's worse than just doing the problem. It's all the accuracy rounding. Huh? Is that making sense then? So there's 2 conditions for a zero to be significant. It's got to be after the decimal and got to have somewhere before it a number that's not zero. So that's why this zero mattered, was significant, and the other zeros don't. So that's why there's only 2 significant digits there.
Yeah, great.
Yeah, that's good. No.
Good. All right.
I'm ready for the test. Let's do the test now.
You're ready. Bring it on. Yes. Okay.
Let's finish it.
So how are we doing? We got 15 minutes. What I want to do, 7, 8, 9 don't look too bad. 10 through 15 look pretty easy. What I really want to show you, what I think would be most needed, most helpful, is to jump down to number 16. Divided by 20. Is that divide or is that add? I'm getting too old. Is that divide or plus? Is that?
Number.
Is it divide? Divide. Thank you.
20.
Yeah, 16. Yeah, divide.
20.
Thank you. Okay. She wants us to do these problems, and then she wants us to give, to round to the allowable accuracy or precision. All right, let me remind you of this. How do you know whether you're supposed to do precision or accuracy?
I don't
You do
know.
accuracy because it's division.
Oh, yeah, she told us.
Right. How'd you know? You just memorized that?
Yeah, just division, multiplication,
Yeah.
roots, and
Multiplying, dividing, and everything else,
Yeah.
roots and
power.
everything else, that's all accuracy.
I remember because I read it this morning when I was doing my homework.
Yeah. That's all accuracy. So this is a multiply divide problem. So you do accuracy. If you have a plus, so I'm trying to make a way for you to remember it. That's how I survived college is memory tricks. So if you're going to do adding or subtracting, I could say plus. Plus is precision, but you might think A for add is so you might not work.
It would be
You might think add is accuracy. I don't know. Adding, subtracting is precision. Let me just write it that way. Somehow you have to know that. That's really important. Adding, subtracting is precision. Here's how I remember it practically. If you're going to add a couple of numbers like 2.03 and 57.6, remember how you line up decimals when you add and subtract? That's because you're looking at the place values, huh? Mm-hmm. So that's how I remember it. I just think adding, subtracting is all about your place value. So it's precision. P with P, remember place value is precision? That's how I remember it. I don't know if that helps you. Whereas multiplying and dividing is accuracy. Accuracy. Okay. So this is dividing. So just use your calculator. I would just simply hit the buttons on my calculator. But then you're going to have to round it right. So on my calculator, I'm getting 0.0040909, blah, 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 blah. That's more digits than I need, I'm sure. Now we got to round it to the correct accuracy. Okay, so all with me at this point, because I'm going to say some important stuff. I want you to not be looking back to something old. You with me?
Yes.
All right?
The place value.
It's the lowest accuracy number. I don't know if you caught that from your last lecture. It's the one with the least. It's always going to be least for either one. It's precision or accuracy, whatever you're doing. It's always the number least. So let's look at this number. Let's look at that number. Let's ask ourselves, who has the least accuracy? Meaning the least significant digits. How many significant digits in this number?
2.
There's 2. Oh, no, 1.
1. Only the 9.
Yeah, because the zero's not after.
Those zeros are not after.
The 9.
Are not after. They're not after a number, another number. 1, and this is 2.
What was your question?
So which of these two has less significant digits?
That's the first one.
The first one, he's only got 1. So that means our answer can only have 1 significant digit. You always have to give the answer according to the least number of significant digits involved in the problem.
It doesn't say least in here, though.
No, you just have to know that. That's from the last lesson. You have to know that when you're multiplying dividing. So I have to take this answer and round it to only 1 significant digit. So who's the first significant digit?
4.
The 4. Look 1 to the right. That's a 0. So 0.004. Done. I hope that's right. Let me look at number 16. Yes, it's right. Did you all track with that? See, that's only 1 significant digit, isn't it?
So when it's multiplication or division, you look at to see which ones has the least, and that's what you mimic.
Right.
Okay.
That's right. Does that make sense?
So the 2 zeros on the left.
So it's 0?
Right, because remember, these zeros don't matter because they're not after
So I'm
a
looking
number.
at the first number, non-zero number after that.
Yeah, you find the first non-zero number.
After the decimal.
Yeah,
And this one I round it. When I
Right.
round.
right. That only has 1 significant digit. Is that good? It's kind of tricky. This is the hardest part.
I'm taking it back. I don't want the test now.
I was ready. Changed my mind. All right, number 17. 23.48 times 7,000. Or is that 7 point? I'm getting too old. Is that 7.000 or 7, 000?
Comma.
Yeah, it's 7,000. Okay. Thank you. So just multiply on your calculator. Just use the buttons on your calculator. Let's get the answer first off. We've got under 10 minutes. We've got like 8 minutes left. We got to get a couple of these so you're getting comfortable.
Get a couple of the other ones.
Let's see. So I'm getting 164,360. But I got to do my rounding thing. We good to there?
Mm-hmm.
164,360, right? Now, look at those 2 numbers we started with. Ask yourself, how many significant digits in the first number?
4.
Right.
And 1.
There's 4. And how many significant digits in this number?
1.
1. None of those zeros matter. They're not even after a decimal.
Not gonna even look at them.
Not even look at them.
No.
So what's the lower amount?
One.
1. So we only get 1 significant digit in our answer. So you got to round that answer to 1 significant digit, right?
So it'd be 2,000?
Take that 1, look 1 to the right, so it goes to 2.
100.
And then just, zeros the rest of the way. 200,000. Yep, that's the answer. This making sense?
Yes.
Something you're going to have to practice between now and Monday.
Yeah, I think me.
Two.
Yes.
All right, so I'm going to go to 18 if we're good on that. Now 18, 12 minus 1.587. Now notice, this one is not multiplying, dividing.
Yes.
It's add, subtract. And add, subtract is all about place value. So it's precision. Everybody with me on that? Remember what I'm saying? That's really important.
Yeah.
So multiplying, dividing, or roots, all that other stuff is accuracy. Add, subtract is about precision, place value. So go ahead and hit the buttons on your calculator. I'm getting 10.413.
So the place value.
So, okay, everybody ready?
Mm-hmm.
Well, how do we know where to stop? It's not about total digits. Remember, that's accuracy. That's all the digits. We're not doing that. We're doing precision, which is place value. So what that means is you have to give the answer in the place value that's furthest to the left. Answer, place value, farthest to the left, where non-zero number is. It's all about a non-zero number. Wait, is that true? Oh.
Only
Click
if.
the answer key.
No.
And I am going to check the answer key. Yeah, I'm thinking right. Okay, I'm not saying it right though. Let me say that a little better. Okay. Never mind on that. I'm not saying it correct. What you have to do is you have to take.
Replace value.
Okay, here let's do the place on this one. What's the place value at which the 12 ends?
No, it's the,
Right there.
it's
The ones.
Ones, yes.
Right? What's the place value where this one ends?
Thousands.
Way over there. So which one is further left? Right? If you lined them up, you'd have 12 and you'd have 1 point. Maybe that's easier. 12 and 1.587. Take the one that's further left. It'd be this one.
It would be the 2.
Yeah. So how about that? I got a new plan. Here's my new plan. Circle the ending on each one. Yeah, there's a better way. Okay, circle the ending on each one. And whichever one is further to the left. So, circle the last significant digit. Can you read that? I'm getting scribbly. Circle the last significant digit for both. Then take the least. Remember, we're always taking the least, which means the left. Least is left. I want to show you that this is almost the same as accuracy. Remember, for accuracy, we took the one that had the least significant digits.
Which is closer to the 0? Closer to the middle?
Further
This
left.
one?
Left. So this one. Which one's further
At least
left?
comparing to what? Where is the comparison point?
Yeah,
What
just think left. Least means left.
Okay.
Just don't even worry about the word least. Just left.
Least to the-
Most left. What that means? Yeah, I don't want to confuse. It means it's the least accurate.
Mm.
That's what that means. Just left further. So notice, what if I had 20 and 7.36? Okay, let's circle. Let me give you. This is the last significant digit, huh? That 0 is not significant with no decimal, and this is. So which one's further left? him. So your answer would be right there in the tens place,
Mhm.
for example. Do you see what I'm saying?
Yes.
So you circle the last significant digit, take the one that's further left. So left is like least. For accuracy, we did least. Here we do left. Same thing. So which one of these? I circled him, so it's this place. It's the ones place. So I've got to end in this place. Does that make sense?
Yes.
Look 1 to the right, it's a 4, 10. Done. That's the answer. That's not easy, huh? So one more time. You circle the last significant digit in each. Line them up. Yeah, I should have said line up. Line up the decimals. I think that's the easiest way to see it. Line up the decimals because it's about place value, right? Precision's about place value. So line up the decimals, circle the last significant digit, and take the left one. That's the place you have to end. We don't care at all about total digits. That's only for accuracy. We're not thinking about that at all. We're just looking at places. That's all we care about for precision, is places. For adding, subtracting, place value, precision. Shall we try another one? Time is running on us.
Yes.
Am I going too quick? Are you okay with that? So what do you do? So for adding, subtracting, it's place value. Line up the decimals, right? The 12 decimal was right there. The 1 point decimal. Circle the last significant digit. Take the one further on the left. Okay. Now what do you do like on number 19? Where you have 7.20 times multiply. So we're thinking about accuracy. But then add. Isn't that an add in the middle there? 0.484 times 370. What do you do when they mix operations?
Do you multiply, and then add?
Right, look at that. We got multiplying and adding. So which one do you do? Do you do precision?
I think I will do the one I'm ending with.
That's it. Did you guys catch that from the last lecture? It's the last operation. Now, what's the order of operations?
We have multiplication first and then addition.
Please excuse my dear Aunt Sally. Did she say
Yes.
that? Please excuse my dear Aunt Sally. Parentheses, exponents like powers and stuff. Multiplying, dividing, adding, subtracting. M and D are on the same level. A and S are on the same level. You just do them left to right. So it's the last operation. So you look up here, guys. What's going to be my last operation then? What's the lowest level operation up there? What's the bottom whenever he's available? Adding, subtracting is going to be last. So what does that mean? If adding, so the last operation,
Precision.
if the last operation is adding or subtracting, then that's place value. Place value, precision. So that's what we're doing here. So therefore, just hit the buttons on your calculator. Let's go ahead and do that. You got to do the multiply first, right? In your calculator, take 7.2 times 9.8. I'm getting 70.56. Multiply those other two, 0.484 times 378. I'm getting 182.952. Then add those together. On your calculator, I'm getting 253.512. We good? But now the hard part. Now the rounding, huh? You ready? So why don't you hold off on the calculator and just write that down because we're running out of time and I want you all to see because it's going to be kind of tricky, the precision. So that's what you hit the buttons later. That's what the calculator will tell you. Everybody got that down? So now are we doing accuracy or are we doing precision?
Precision.
Precision. How do we know?
Addition.
It's the
Because the last operation was adding, subtracting. Whatever's last tells you. Now, how do you do it? What did we learn about precision in the last problem? What did we do? Line up the decimals of the original. I'm going to go back to the original numbers. Line them all up, circle the last digit for both, take the one on the left. So here we go. 7.20, 9.8, 0.484, and 378. See how I lined all the decimals up? See what I'm saying there? Line them all up. We're good there? They're all lined up. Now circle the last significant digit for each one. So 7.20, let's start with him. Is that 0 on the right? Is that significant? Yes. He's after the decimal and he's after a number that's not 0. We know he's significant, huh? That 8 is significant, that 4, and that 8, right? Those are all the significant digits. Usually the last digit. Okay, now which one do we take? What place? It's all about place. We don't care about total digits. Precision is place value. What place value is furthest left? Which one's left?
The 8.
Yeah, this guy. So that's the place we must stop in, which is right there, isn't it? It's right, first place to the left of the decimal. We must stop there. Look 1 to the right. It's a 5. 254. I sure hope that answer's right. Yes. I think we've got it down. That's the right answer.
I don't know what you did.
It's magic. Sleight of hand mathematics.
Wouldn't multiplication be the last?
No. No, I added here at the end. Remember, I multiplied those two, and then added last.
Oh, okay, I got it.
Yeah, remember the order of operations. Adding and subtracting is last when they're both in there together. Please excuse me, dear Aunt Sally. There's a lot to remember, huh? So does everybody see what I did there at the end? So if the last operation is adding, it's precision, place value. Line them all up, circle the last significant digit, take the one on the left.
So 20 would do the same thing because it's add and subtract.
Problem is, you're going to divide that last. Do you see 20? You're going to divide last, right? 20 is like a trick question. 5 minus 2.7 over 15 plus 18.1. What are you going to do? Just tell me. What would you do real life? Wouldn't you subtract first on the top?
Yep.
You would. That big old bar is separating, meaning you do that last, huh? That'd be 33.1, I think. And then you would divide last, wouldn't you? You go 2.3 divided by 33.1. That'd be right. And you get 0.069486, blah, 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 blah. So what did I do last?
Division.
Divided last. Yeah, so let me just mention, one big bar means that you divide last. And you know that, huh? You don't need me to tell you that. You just know by the look of it that you do the whole numerator, the whole denominator, and you divide last. A big bar is a separator. So I divided last. So what? What does that matter? So that means this is accuracy, not precision place value. Remember, because whatever you do last dictates. He's the ruler. He says what goes. So this would be an accuracy issue, wouldn't it? So accuracy, we don't care about place value. We just care about significant digits. So let's take the numbers. 5, 2.7, 15, 18.1. Let's write down how many significant digits for each of those, and the least wins. Am I going too fast? You with me? I just wrote down. You always write down the original numbers. If it was place value, I'd line them all up, wouldn't I? If this was precision or place value. If I'd added last, then I'd be doing precision place value. I'd line up the decimals. But I didn't. This is accuracy. So yeah, this has 1 significant digit. This has 2 significant. This is 2 significant. And this is 3 significant. So which one has the least significant? 1. So I'm going to take my answer, my 0.069486, and go 1 significant. Remember, you always do least or left. Least for significant digits, left for precision place value. Huh. Least or left. So what's the, so I got to do that answer to 1 significant digit.
Are you recording this?
Yes, I am.
Okay.
You can watch it again later.
Keep going.
You can rewind it and play it. You'll even hear what you just said right there at the end. So what's the first significant digit?
Oh, the 6.
6. Look 1 to the right. 0.07.
0.07.
Let's double check. I sure hope that's the right answer. Yes, we're just rolling. That's it.
The significant. The 0 is not significant.
Right, because it's because there's not a number that's not 0 before it. All right, well, we're kind of out of time and overtime. So I will post this. I'll do it right now.
You can't do